Hi, my name is Ryan Bliss, a product manager on Teams platform.
Hi, my name is Pradeep Panagaraman, a software engineer on Teams platform.
We're here to talk about building interactive meeting extensions in Teams using our new LiveShare SDK. As modern workplaces transition from from home to hybrid, we hear a lot about the frustrations that can come with digital collaboration. In Teams meetings, a glass screen sits between you and the other people you work with. With the new Teams LiveShare SDK, we've combined the power of Fluid with the social network of Teams. Any front-end developer can transform their web app into a delightful multiplayer experience.
By the end of the session, you should have a good overview of our SDK and scratch the surface of building any collaborative app through two sample walkthroughs, a media watch together app and an agile poker planning game. Let's dive in.
For those who missed other announcements and sessions, there are 4 key areas of the LiveShare SDK. First, matchmaking is automatic and backed by the security of Teams meetings. We do all the legwork so that your front-end teams can focus all their time on building rich, interactive features that augment meeting collaboration.
Next, we have made a new ephemeral fluid data object, such as ephemeral state and events that can be tailored to meeting roles and context. These are extensions built on Fluid Framework's data objects that are transient and ideal for scenarios where storing objects may add complexity, such as laser pointers or notifications. They're also the only Fluid objects that support meeting role and verification.
We've also built a tailored set of media synchronization capabilities based on our ephemeral objects to synchronize audio and video files in just a few lines of code. As people talk to each other during the call, media audio is intelligently reduced so that people can hear each other clearly.
Finally, this preview service is fully managed, scaled to all Teams customers, and available today. This service is backed by Azure Fluid Relay, which is currently in preview and will be generally available this summer.
Let's look at our first demo, where we will walk through a video template app available in our GitHub repository. Pradeep and I are in a meeting where we have a local app running on my computer tunneled through ngrok, so we can both try it live. As you can see, I have a meeting side panel extension with a list of videos.
Here, let's watch this one.
Awesome, I see it. Since you're in control, want to press play?
Sure.
As you can see, the video is now playing for me, and I got a notification saying that Pradeep paused the video. If I try and pause the video, it does pause, but because I'm not the presenter, it only pauses for me. Pradeep, is it still playing for you?
Yes. We add a feature called suspensions, which is especially useful for people with disabilities like epilepsy, but it's important they be able to pause a video that may trigger symptoms without disrupting the rest of the group.
Awesome. When I click Follow Presenter, it automatically returns me to Pradeep's position. I'm going to take control now so I can go to the next track. The next video in the playlist is loaded, and you can see that the side panel updates as well.
Let's talk through how we built this app. First, let's review the Teams app manifest changes needed to use the LiveShare SDK and related features. If you aren't familiar with the Teams app manifest, you can learn more at aka.ms/Teams platform docs.
At a high level, this is a JSON structure that tells the Teams client what your app capabilities are, what permissions a user must consent to use them, and other information about your app. Teams has a feature called tabs, which allows you to build web applications that can be pinned to various contexts in Teams. The two that are supported by Teams LiveShare for now are Meeting Side Panel and Meeting Stage.
There are also a few resource-specific authorization permissions worth noting. First, to enable the LiveShare SDK, you must include LiveShare as a delegated permission.
Second, if you want to use the Meeting Stage tab context, you must also have the accompanying Meeting Stage permission. But if your project requires the Meeting Side Panel context, then this isn't required.
Finally, if you want your app to support intelligent audio ducking, which reduces video or audio volume when synchronizing media playback, then you should include the online meeting incoming audio permission.
In case you didn't see in earlier sessions of the conference, here is a simple example of how to set up a Teams Fluid client in just a few lines of code.
The first thing you do with any LiveShare project is define your Fluid document schema, which can find more information on from their docs at fluidframework.com. At a high level, you're choosing your shared model layer, a set of shared objects.
There's effectively no limit to how many shared objects you define. Ephemeral Media Session is an example of a shared object that we've created to simplify media synchronization in Teams.
Next, we initialize our Teams Fluid client, get our container object by calling join container method of Teams Fluid client with the defined schema, and you're free to start with writing your app logic. Let's see how this is done in our media sample app. Okay, great. Now that we have covered the basics, let's pull up the code. We are looking at the meeting stage page. where we have some hooks we've added to cleanly separate the code related to each object in our Fluid schema.
The shared object hook exports each of the objects for our container. In your project, you could use this hook as a template if you'd like, but you certainly don't have to.
Now, let's look at the side panel.
As you can see, the side panel is also using the same shared objects hook, but in this case only uses the playlist map object.
This should allow us to selectively synchronize data between these two pages, since each is actually a separate web view within the Teams client, right?
Exactly. It's now much easier to use the meeting side panel as a companion experience to your Stage app. Let's talk about the shared objects hook for a second before talking about the playlist feature. The use shared objects hook has one job, which is to create the Fluid container and export relevant shared objects to our UI. We have two React state properties, one for the Fluid container results and another for any error that may happen in joining the container. The React effect hook is responsible for the initial setup, which in this case is when the app first loads. Pradeep, can you talk through this connection code we see here?
One awesome thing about building interactive experiences through this SDK is that you can test either locally in your browser or in Teams. In this hook, we check to see if there is a URL parameter with in Teams is set to true. Otherwise, we set up the local connection using Azure Fluid Relay's local testing client. This is totally optional.
Got it. I also see these Teams Fluid client props, which I see are also optional.
That's right. We are defining a Fluid debugger, which is helpful during development, as well as the connection setting that gets set when testing locally.
If you prefer testing in Teams or disabling the debugger, you don't have to define your props at all. Next, we are defining an onFirstInitialize function, which is another optional parameter. This is really helpful for setting any initial state when the Fluid container is first created. Here is the only truly required part of our setup, where we define our Fluid schema. In this example, we have 5 components. Pradeep, what do each of these components do at a high level?
The presence object is responsible for tracking who is online and relevant metadata. We'll talk about that in our second sample. The media session object is responsible for synchronizing our media player. The notification event object can send transient push notifications to everyone currently in the session. Our take control map lets us track the presenting user. Finally, the playlist map tracks our list of videos and which video is currently selected.
Once the schema is defined, we initialize our Teams Fluid client, join the container by passing in the schema and optional onFirstInitialize callback, and then set the response to our app state. Once the container is created, each object in our container will no longer be undefined, so any components taking a dependency on these shared objects can start using them. Pretty straightforward. Pradeep, can you give an overview on Fluid's shared map?
Shared map is just one of the built-in objects in the Fluid framework, so some of you may be already familiar. Shared map is a synchronized key value store, very similar to a standard map or a dictionary.
Once you've created your map, you can start listening to changes using the onValueChanged listener.
Know that if 2 people set a key at the exact same time, conflicts are resolved based on last writer wins.
Changing a value will trigger the value change listener that we defined earlier, so that each client can update their UI accordingly.
Shared map is an incredibly flexible detector that can be used for almost anything you want to synchronize, but there are a few caveats.
All data stored through our hosted service is deleted within 24 hours of container creation. Don't put anything in the service that you aren't prepared to lose.
Another thing to keep in mind is that these objects are not compatible with the Teams meeting role verification, so anyone in the session can write to these objects.
For most scenarios, that shouldn't be a big deal, but it's good to know. Anyways, let's see this in the code.
We are now looking at the playlist hook, which takes in our playlist map object. We have defined a few state properties through React state hook, including media items, a list of videos in the shared playlist, selected ID, the currently selected video in our UI, and a started flag, which tells us when our event listener is registered and the component is ready to go.
How much of this code is business logic as compared to SDK related code?
Almost all of it. The awesome part of Fluid is how simple it is to synchronize any object. So most of the code here are app state, computer properties, and callback methods we expose to our app UI.
Here is where we start our setup logic. First, we add our event listener, which refreshes our UI with the latest information from the shared map. We then get the initial values.
The rest of this file is a series of methods related to setting data to the map, such as select media ID. These each get exposed to the UI.
Let's go back to the side panel page and see how these are used.
In our render section of our code, we take each media item and map them into a media card component. When the Watch Together button on the media card is clicked, we set the selected video ID in our playlist map. If sharing is active, we share the video to the meeting stage using the Teams client SDK. Otherwise, we skip this step, since doing so would cause the page to reload.
Building synchronized objects into your UI is as simple as that, but we aren't done. Let's go back to the meeting stage component to look at a couple of our other hooks. The meeting stage page uses the same playlist hook as the side panel, but also uses all of our other objects. Pradeep, can you walk us through the notifications hook?
Sure thing. First thing you will notice is it takes a single input, which is the ephemeral event object returned from our shared objects hook. It exports a flag indicating that it is successfully set up, the most recent notification to display, and a send notification method. The ephemeral event object allows you to broadcast out any JSON object to other clients in a session. After adding it to our Fluid schema, we can set an on-receive listener, which will be triggered every time an eligible client calls the send event method.
The main difference between Fluid shared objects and our ephemeral ones is that ephemeral objects have an explicit start method. Here, you simply initialize it with an optional roles parameter, allowing you to choose which meeting roles are eligible to send events through this object.
Let's look at this in our code.
This code is pretty straightforward. Similar to the sample, there is a send notification callback method, which sends a JSON object with a text string. In our received event listener, we update our local app state with a notification to display, formatted differently for a local user than a remote one. We then call the start method, set started to true, and send an initial join notification.
To enable media synchronization in our app, let's add our ephemeral media session object to our Fluid schema. Then, we create our media synchronizer by passing our HTML5 video or audio element into the media session object.
Next, let's define the roles we want to allow playback control and call the start method. That's it for synchronizing the player for non-controlling participants, but there is one more important distinction.
Most modern web browsers weren't designed to distinguish user-initiated actions such as pause and play. This means that events such as buffering are indistinguishable from a user pause action.
To avoid this, it is important that our media synchronizer be able to intercept user actions, including pause, play, seek, and set track.
If your project doesn't have custom media controls, we have template available in our GitHub repository based on Fluent UI.
All right, let's look at this in action. The media session hook is responsible for synchronizing our media player, which in this case is powered by Azure Media Services. Pradeep, can you walk us through this?
First, let's go down to where we set up the media session and synchronizer. If the local user is in the current presenter, we set the synchronizer to view-only mode, which blocks synchronous playback methods from being applied to the player. Next, we mute the player by default, since we don't capture a click needed in some browser before playback starts. For your app, you may want to investigate more creative ways to work around this requirement. Now, let's look at our playback control methods. Since most of these are similar, we won't look at all of them. Let's look at the pause callback. If the local user is the current presenter, we call pause through the synchronizer, and a notification is sent to the other users. Otherwise, we temporarily suspend synchronization for the local user and pause the video. Let's now look at how this gets wired up to our UI.
Our app uses Azure Media Player, which has a slightly different interface than HTML5, so we created a simple shiv that makes Azure Media Player match the interface of HTML5. If you use a different player, you can follow the shiv pattern established in our documentation. When all our components are set up, we stop showing the Teams loading indicator through the Teams client SDK. Finally, we have a media player container with a video element as a child, per the Azure Media Player guidelines. We then pass in relevant information for the player controls, such as the Azure Media Player object, whether playback is suspended, and our callback method, such as play and end suspension. That's all we needed to make a robust media synchronization experience in Teams. Next, let's talk through an Agile Poker demo app, which uses a planning methodology used here at Microsoft. I am a Scrum Master trying to determine the amount of time it will take to build a watch together experience for our user testing app. I click the Plan Together button, which shares it to the meeting stage. I then click Start Game, and Pradeep and I can guess the cost from a list of cards. I'll make my guess, and then click Submit, and Pradeep will do the same. Pradeep, what did you guess?
I guessed 5 story points, because while we have some good templates available to us, we still want to make sure the experience is good.
That makes sense. I guessed lower because of the templates, but I think you're right. Let's try again. Now that we have consensus, I click Finish, and the side panel is updated with the agreed value. This app works similarly to this media sample, so we won't cover all of it, but let's look at a couple of new shared objects from the sample.
Our poker app uses a new concept called ephemeral state, which allows for stateful object that lasts as long as one client is connected to the session.
Like our other components, you must first define poker state in our schema. We can then listen for a state changed event, which exposes 3 properties: state, value, and a local user flag.
Next, we start synchronization by choosing which roles can change the state. This component is a great alternative to standard fluid objects in cases where you still want role verification. Let's see how we use it in our app.
At a high level, this app is composed of 3 primary states that only the meeting organizer, or Scrum Master, can change, each mapped to corresponding UI. If we scroll back to the top, you can see that we've used the same shared objects hook that exposes relevant fluid objects used in the sample, including a poker state, presence, timer, and user stories map. Pradeep, can you walk us through poker state?
The poker state React hook manages our ephemeral state object. This hook is responsible for managing the current step of our planning activity, exposing the current state, selected user story, and callbacks. Looking inside the hook, our setup looks a lot like the slide we showed before. Inside of our listener, we check to see if the state is a valid one, then update our UI with the latest state. We restrict state changes to only the meeting organizer and start listening for state changes. This is what our change state method looks like.
Next, let's talk about another ephemeral object called ephemeral presence. Presence makes it easy to track who is online and assign user attributes such as name and profile picture.
The important thing to know about presence is that each user self-reports metadata about themselves. This means that nobody can synchronize data for another user.
Presence updates are sent at a default interval of 60 seconds. If no presence update is sent after 2 intervals, their status will automatically switch to offline.
Like other objects, you must first define ephemeral presence in your fluid schema. You can then listen to presence change event, which exposes a user presence object and a local flag.
When you start presence, you can optionally define a user ID and a custom data object. To change data about the user, you can call the update presence method.
Let's look at how we use presence in our sample.
The presence hook takes in 2 parameters, the presence object and user ID. In this case, from the getContext API in the Teams client SDK. This returns our list of users, the number of users who have readied up during the costing phase, a flag indicating whether the local user is the Scrum Master, and callbacks for updating user attributes. Let's check it out.
Like any ephemeral object, our setup logic is composed of an event listener and a start method. As we mentioned earlier, our app relies on one person, the meeting organizer, being in charge of changing states, so we get the roles for our local user. We will then filter out list of users to those online, and then update our UI accordingly. If we want our presence to update more frequently, we can always change the interval. We then assign default user attributes and start presence tracking. Regarding the callbacks exposed to our UI, they all follow similar patterns. Let's look at the report answer method.
During the costing state of the game, we request each person estimate the user story cost associated with the given user story. When the costing run is over, either because the timer runs out or each user has readied up, each client reports their answer using this method. This data is then used to render the answer for each user in the discussion phase. With Teams LiveShare and Fluid, front-end developers can build incredible interactive experiences without complex back-end work.
We can't wait to see what you build, and thank you so much for attending our session. If you want to learn more, you can find our docs and samples on GitHub at aka.ms/Teams LiveShare.
You can also tune into other related sessions. Hope you enjoy the rest of Build.